Good morning, ma'am. Ang didiscuss namin po ngayon ay the layer of atmosphere. Meron tayong 5 layer of atmosphere. Question, what are the 5 main layer of atmosphere? At syempre, meron din mga katangian ng bawat layer of atmosphere. Earth atmosphere is divided into 5 main layers based upon change in temperature. The first layer is troposphere. The troposphere, this is the first layer of atmosphere close to the Earth's surface, attending up to about 10 to 15 above the Earth's surface. Troposphere, kung saan nagaganap yung mga typhoon, rainy season, and mga hurricane. Nakapaloob sa troposphere yung mga yon. Stratosphere type po yan. This layer is least directly above to the troposphere and it's above 35 kilometer deep. It extend from about 15 to 50 kilometers above the Earth's surface, kung saan po lumilipad yung mga airplane para po settled po silang lumipad, hindi po sila nag-iibang pwesto or yumuyugyog, ganon. Kasi po yung temperature doon settled po, hindi po nagbabago. Mesosphere. The mesosphere is the third layer in the atmosphere. It is extending from 50 to 80 above the Earth's surface. The temperature drops when you go higher. Kung pupunta po kayo sa mataas pa sa mesosphere, kung pababa po nun, mag-iiba po yung temperature dahil po yung mesosphere is...
And ang pangalawang layer po natin is patungkol sa thermosphere. Base po sa pangalan niya, nag-umpisa sa thermo. May kahulugan na init. Dito sa layer na to, dito na po nag-uumpisa na umiinit na yung temperature. And, dito sa layer po na to, medyo mainit na po dito dahil maabot na po siya ng at least 1,500 degrees Celsius. And, according po sa nabasa namin, dito po sa thermosphere na to, dito po umiikot yung mga satellites, mga spacecraft, o yung mga pinapalipad ng mga meteorologists. Then, dito din po sa layer na to, dito po natin nakikita kung nakapunta na po tayo ng moto na papanood po natin sa mga television natin. Dito po nangyari yung mga auroras. Auroras o yung mga polar lights. And may dalawang uri po tayo ng auroras. There is in North Pole and South Pole. Sa North Pole po, dito po ang tinatawag na auroras borealis. And sa South Pole po, dahil nakapangalan po sa kanya, ito po yung tinatawag na auroras australis. Kumbaga, nakikita po siya kadalasan sa Austria. Then, exosphere. Exo means outer na po siya. Ibig sabihin, pinakauli. Ito po ay nagko-compose ng hydrogen and helium. Dito po sa layer na to, sobrang nipis na po ng hangin o oxygen. At kung mapapadpad ka man po sa layer na to, panigurado, ikaw na po yung pinakamalayong napuntahan. Ikaw na po yung pinakamalayo between the Earth. And base po sa research namin, umabot po siya ng up to 26 to 28 kilometers far away from Earth.
I am going to discuss about ozone. But first, ano nga ba talaga yung ozone? Ozone is composed of 3 oxygen atoms. It also called trioxygen because it has 3 oxygen atoms. It is both natural and man-made product that occurs on Earth. And its chemical formula is O3. Next. Atmosphere of Earth has 5 layers: the exosphere, thermosphere, mesosphere, stratosphere, and troposphere. Ano nga ba talaga yung connect nito sa ozone? Masasagot niyo sa next slide. Where can we find the ozone? We can usually find the ozone on the middle of the stratosphere and troposphere. But most of the ozone is usually found on the stratosphere. Here, we can find ozone in the middle of these two, the stratosphere and we can find most of the ozone here in the stratosphere. Then we are living here in the troposphere. Why ozone is important? The main function and the main job or the most important job of the ozone is to act as a shield on the living organism like plants, animals, and people on Earth. Ozone is blocking a type of radiation. This radiation is called ultraviolet radiation or UV light. This UV light can be both harmful for plants and animals. For plants, if plants expose too much UV light, it will quickly kill them. For people, when we are exposed, if we are exposed in the UV light for a long time, it may cause diseases. Katulad na lang ng pagkabulag or even cancer, like skin cancer mostly.
What is weather? Define the condition at any point or short period of time in the atmosphere. Weather conditions can abruptly change. When you look outside, you will be able to observe the condition of the atmosphere. Condition of the atmosphere gives a hint regarding the kind of weather that you will experience for a day. The condition may change within a short period of time, sometimes in a matter of hours or days. It can be classified as sunny, windy, cloudy, snowy, and stormy. So next is meteorology. It's called the science of studying nature, temperature, rainfall, pressure, humidity, sunshine, and cloudiness are calculated by weather scientists or meteorology. Meteorology makes it possible to understand how these natural events are formed and how they evolve in time and space. This study makes it possible to establish weather forecasts, but this science is complex and not always reliable. Next is thermometer. It's used to measure the temperature or the warm or coldness of material. Elements of weather. The weather is the daily atmospheric condition consisting of precipitation, temperature, humidity, wind, and sunshine. So, what is precipitation? Refers to the moisture of the atmosphere. It can manifest itself as rain, snow, hail, or fog. Next is humidity. It's the amount of water vapor in the air. Temperature is the degree of hotness and coldness of the air is known as temperature, which change not only between day and night, but also from season to season. Next is wind. It's the movement of air. Last is sunshine. It's the amount of rays, light, and warmth of the sun from a particular location. Next is the causes of weather. The amount of solar energy received because of latitude. Tilt of the earth causes different areas to receive different amount of solar energy. The lowest latitude gets the most energy from the sun, while the highest latitude have the less heat. Next, the area's elevation or proximately to mountains. The higher the elevation, the lower the temperature. Mountain areas are generally colder than surrounding land due to highest altitude, nearness to large bodies of water, and relative temperatures of land and water. Proximity to water moderates the climate, while inland, climates are harsh. The number of such storm systems as cyclones, hurricanes, and thunderstorms resulting from air mass differences. On this one, cyclones represent areas of low pressure and are therefore also known as low pressure systems. Let's proceed to the factors that influence weather. Number one is the cycle of water. Water rises in the form of water vapor from streams, rivers, seas, plants, the atmosphere, and other sources as the sun warms the surface of the earth. Next is air masses. It takes on the features of the area below when air hovers for a while over a surface area of uniform humidity and temperature. Jet stream. Jet stream is the name given to the area of air above where two air masses of different temperature converge. Cold front with a warm front. Next one is the weather front. A front is the transition zone between two air masses with varying humidity and temperature. Average and extreme already explained, and it's just like temperature and humidity.
Climate, it is a weather condition prevailing in an area, in general, or over a long period of time. Next is temperature. It is the degree of hotness and coldness. It is also affected by the solar radiation reaching the Earth's surface. Next, humidity. The amount of water vapor in the air. It is invisible. Humidity indicates the probability of precipitation to or fog. Precipitation. It is the water falling from the atmosphere onto the Earth's surface in the form of rain, snow, or hail. Next is pressure and wind. Pressure, it is the force caused by the weight of air on Earth's surface, while wind is the movement of the air. Climates of the world. There is three climates of the world. Number one is tropical climate. Ito yung located sa 30 degrees above and below the equator. Dito din makikita yung sun na nag-overhead at noon. Middle latitude climate naman, located between 30 degrees to 65 degrees latitude. It is where the average temperature is 10 degrees Celsius or higher. Polar climate. It is close to the poles. The sun is not seen, bringing winter for as long as 6 months. Climate change. Global warming. Because in the last few decades, because of human activities, mas lalong tumataas yung global warming na nagkakos sa atmosphere na mag-store ng mas maraming init than usual. Kaya nagre-raise yung temperature ng Earth. Ano ba ang mga consequences ng global warming? First is, because of the warming of Earth's poles, makes the ice melt, which raises the level of our oceans. Dahil nga sa pagtaas ng temperatura na nag-create ng drought and desertification, ang nangyayari, yung mga plants and animals ay hindi na nakakapag-adapt at sila ay namamatay. Solution to climate change. Maraming pwedeng maging solusyon sa climate change. Number one is no deforestation, para every time na nagbabaha is hindi agad-agad lumalaki yung tubig. Plant more trees and plants, no contamination, and do recycling. For example, sa bahay naman, kapag natapos na gamitin ng electricity, pwede na i-turn off yung TV or light para hindi masyadong mataas yung pagkukonsume.
What is orbit? An orbit is a regular, repeating path that one object in space takes around another one. An object in an orbit is called a satellite. Orbits come in different shapes. All orbits are elliptical, which means they are an ellipse. What causes an orbit to happen? Orbits are the results of a perfect balance between the forward motion of a body in space, such as a planet or moon, and the pull of gravity on it from another body in space, such as a large planet or star. How orbit works? These forces of inertia and gravity have to be perfectly balanced for an orbit to happen. If the forward movement, inertia, of one object is too strong, the object will speed past another one and not enter orbit. That's how orbit works. These are the references. And ito po yung module na nagawa ko. Module about orbit. This is Dr. Werner E. Suomi, a Russian satellite Sputnik, initiated or exciting exploration of space and changes the course of technology. Ito po yung module na tinatakil dyan and yung mga matutunan natin. Satellite orbits. Yan lang po. Geostationary orbit.
There are 9 content in convection connection na makikita niyo sa PowerPoint ko ngayon. Pero mas magpo-focus ako and na-explain ko yung convection and convection in the atmosphere. Before we proceed to the convection in the atmosphere, my question is, what is convection? Convection is probably a word that you heard a lot when you study heat transfer. Along radiation and conduction, convection is a way that heat transfer through matters. But unlike radiation and conduction, convection is only happen in fluids. But by the way, what is fluids? Fluids is a liquid gases that states of matter where molecules can move around freely. Convection happens in the atmosphere. In the atmosphere, there are large convection cells called Halley cells. Because of the angle tilt of the position of the sun, the crater receives that much more consistent heat in the sun and the polar regions. Yung energy na nakukuha natin sa sun is nanggagaling naman sa radiation. Down here, the Earth's surface that absorb energy from the sun is supposed to be geosphere. Yung geosphere na tinutukoy ko dyan is yung kulay green. Ngayon, doon sa center ng kulay green na geosphere na sinasabi ko is makikita natin yung dark color brown. Yung dark color brown is like, example, tayo nagsuot ng damit na kulay black tapos nagbilad tayo sa araw. Then yung na-absorb ng damit natin yung energy or yung init. Bali parang ganun lang. Sa may center ng color brown, may makikita tayo ng dark blue bulb or yung circle blue bulb. That air is getting a little bit more warmer than its surroundings. But the particles inside the blue bulbs are moved faster than the gas and its surroundings. But in the middle of the blue bulb, it has a rising thermo. Why is it rising thermo? It is because its surrounding and the warm air is less than more when it's buoyant. So if it's moving faster, more thermo energy expands, and if it's expand, it will become lightly flat like this. In the next figure, it illustrates also the convection in the atmosphere. First, it also have rising thermo warm air. Rising is actually continue to expand, and when it expands, it will cool down. And one thing about the water gas is that we can go ahead and get water gas to liquefy if we cool it down, and that's what thermos doing. So I'm not only showing you this kind of convection, relocating warm air or thermal energy, but also I want to show you this kind of jump of air. If it has water molecule or water gas particle in it, it will cool down to the point of condensational level. And there is an elevation that we call lifting condensational level. Lifting condensational level, also called LCL for short. And it's the point where water vapor is becoming cool and it's gonna head and liquefy.
So, in this lesson, we will talk about heat of convection. But before that, what is it all about when we say heat of convection? So, heat convection is a mode of heat transfer by the mass motion of a fluid such as air. So, also, heat convection occurs to the surface of an object where the surrounding fluid of object is heated and moved energy away from the source of heat. So, convective heat transfer occurs when the surface temperature differs from that of surrounding fluid. So, that is heat of convection. So, to find out how convection transfer heat from the atmosphere, tingnan natin ang figure 3 kung saan ipinapakita dito kung paano nagtatransfer. Yun nga, yung heat sa atmosphere. So, in figure 3, or the convection in the atmosphere happen when the heating of the Earth's surface and atmosphere by the sun drives convection in the atmosphere and ocean, producing winds and ocean currents. So, to explain it more on how convection transfer heat from the atmosphere, ihalin tulad natin ito kapag nagpapainit tayo ng tubig. So, a simple example of condensation through convection can be performed by placing a pot of water on a heated stove. So, the burner represents the heating of the Earth's surface by the sun, while the water and the air above it represents the atmosphere. So, as the bottom of the pot or the Earth's surface begins to heat the water or the lower atmosphere, warmer and less dense water evaporates and rises, or the thermal, into the drier, colder air above the pot, or the middle atmosphere. So, this causes the thermals to cool and water vapor within to condense, forming a small cloud, or steam that is visible above the pot of heated water. So, the same process occurs in the real atmosphere as the water vapor within rising thermals condenses to form a cloud, as occurred in placing a pot of water on a heated stove.
Coriolis effect. Coriolis effect is the phenomenon when an object that are on or above the Earth's surface drifts sideways off course than what is intended to be. This is because of the Earth's rotation. If an object on a plane that has a rotating coordinate system, it will look like that the object is being deflected from its path, when in reality, the object stays on its path and it only appears that it is deviating because of the movement of the coordinate system. So how does the Coriolis effect look like? The air moves westward on the northern hemisphere, and on the southern part of the Earth, however, it moves eastward. This wind movement affects those at sea and air. So if we flatten the Earth and look at the diagram, we can see why they move like that with easier comprehension. So this is the diagram. Let's say that the green part is the Earth, and it is rotating as seen on the color blue line. Now let's try to split them up for easier understanding. So this is what they look like when they are split apart. This is the northern hemisphere, and this is the southern hemisphere. This blue line represents the rotation of the Earth. And let's say that this red line is an object that moves from one end of the blue line to the another. As you will see, the blue line will only take the path from one end of the blue line to the another end of the blue line. So this is how the Coriolis effect look like. Now let's try to trace the red line, and we will see why it rotates like that. Like why our weather system rotates like that. So let's put a tracker on one corner of the red light and let's see what happens. So that's what it looked like. As you can see, it looks spiral like our weather systems. So that's what Coriolis effect is. Thank you.
Ocean water is on the move, affecting your climate, your local ecosystem, and the seafood that we eat. Like air in the atmosphere, ocean water moves in currents. A current is a stream of moving water that flows through the ocean. Currents are cohesive stream of seawaters that circulate through the ocean. Some are short-lived and small, while others are vast flow that take centuries to complete a circuit of the globe. There are two distinct current systems in the ocean. The first one is the surface circulation, which steer a relatively thin upper layer of the sea, and the deep circulation which weave along the deep sea floor. Ocean currents, abiotic features of the environment, are continuous and directed movement of ocean water. These currents are on the ocean surface and its depth, flowing both locally and globally. Ocean currents are driven by a range of sources: the wind, tides, changes in water density, and the rotation of the earth. The topography of the ocean floor and the shoreline modifies those motion, causing currents to speed up, slow down, or change in direction. Currents are generally measured in meters per second or in knots, which is equals to 1 knot equals to 1.85 kilometers per hour or 1.15 miles per hour. Earth's rotation results in Coriolis effect, which also influences ocean currents. The Gulf Stream is an ocean current that carries warm water in the western coast of the United States and Canada and on the western Europe. This strong current warm water influences the climate of the east coast of Florida. Given temperature, they're warmer in the winter and cooler in the summer than the other southeastern states, since the Gulf Stream also extends toward Europe. It warms Western European countries as well. The picture in this slide is depicting the map of temperature of the North Atlantic Ocean, shows the warm Gulf Stream current along the east coast of the United States, transporting heat northward towards the cooler high latitudes. Ocean currents fall into main categories: the surface current and the deep ocean current. The surface currents control the motion of the 10% of the water, while deep ocean currents mobilize the other 90%. The first category is the surface currents are caused mainly by winds but not daily winds. Surface currents are caused by the major wind belt. This wind blows in the same direction all the time, so they can keep water moving in the same direction, just like in the picture in the slide. The next one is the deep ocean currents. Differences in water density resulting from the variability of water temperature and salinity also causes ocean currents. This process is known as the thermohaline circulation. In cold regions such as the North Atlantic Ocean, ocean water loses heat to the atmosphere and become cold and dense. When ocean water freezes, forming sea ice, salt is left behind, causing surrounding seawater to become saltier and denser. Dense cold salty water sinks to the ocean bottom. Surface water flows in to replace the sinking water, which in turn becomes cold and salty enough to sink. There are factors which ocean currents are driven, which are the rise and fall of the tides, wind, and the thermohaline circulation. The first one is the rise and fall of the tides. Tides create a current in the ocean, which are strongest near the shore and in bays and estuaries along the coast. These are called tidal currents. Tidal currents change in very regular pattern and can be predicted for the future day. In some locations, strong tidal currents can be traveled at speed of 8 knots or more. The next one is the wind. Wind-driven drive currents that are or near the ocean surface. Near coastal areas, wind tend to drive currents on their localized scale and can result in the phenomena like coastal upwelling. On the more global scale, in the open ocean, wind drives currents that circulates water for thousands of miles throughout the ocean basin. Our planet's rotation produces a force on all bodies moving relatively to the Earth. Due to the Earth approximately spherical shape, this force is greatest at the poles and least at the equator. The last one is the thermohaline circulation. This process driven by density differences in water due to temperature or thermo and salinity or haline variation in different parts of the ocean. Currents driven by thermohaline circulation occur at both deep and shallow ocean level and move much slower than tidal or surface currents.
Hi, I am Sam Laxamana of the SCPE 1A, and I'm here to discuss and present to you the relationship between the ocean and the atmosphere and how they interact with each other. But first, before we go to the PowerPoint and basahin lahat ng mga inihanda kong information doon, gusto ko muna simulan to sa similarities between the ocean and the atmosphere, between the sea and air. First similarity nila, both contains H2O.
pero in different forms. Sa atmosphere, ang H2O doon is in gas form or what we call the water vapor. And sa ocean naman, it has H2O in liquid form, which we call the seawater. At ano pa yung isa nilang similarity? Bigay pa tayo. Siguro given na yung both the ocean and the atmosphere, they're in the Earth's surface. Diba? And another similarity is not all bodies of ocean pareho ang temperature. May parts sa mga ocean or bodies of water na mainit, sa ibang bodies of water ng ocean malamig. Kagaya ng tropical seas, dito yung mga warm waters, or the warm seas. And then the colder seas, mga seas or bodies of water sa ocean na nasa North Pole and South Pole. Ganun din sa atmosphere natin. Hindi yung buong atmosphere ng Earth is pare-pareho ang temperature. Example, kaya nga sa mga ibang lugar may init yung atmosphere nila, maulan yung mga lugar na yun. And sa mga malalamig na mga lugar, nagsusnow dun. Snow naman dun. Kaya hindi pantay-pantay ang temperature sa atmosphere and sa ocean. Para silang salamin, di ba? Now, let's get on with it sa discussion natin sa PowerPoint here. The air-sea interaction. The air-sea interaction describes the dynamic, thermodynamic, and biogeochemical processes that link the atmosphere and the oceans. So dito, parang sinasabi na nagpapasahan ng init ang ocean at ang air. Parang nagkakaroon ng cycle na madidiscuss natin mamaya. And sa second point natin dito, sinasabi dito na ang energy na nanggagaling sa ocean at sa atmosphere nanggagaling talaga sa sun. Kasi sabi dito, the ocean stores incoming energy from the sun and then transfers heat and moisture to the atmosphere that fuels its circulation. So yung nanggagaling pala na init, sa air and sa sea, galing sa araw. At yung energy na yon dumadaan lang sa mundo natin, sa Earth. Pero ang ocean para siyang nag-a-act na salamin. At parang nag-a-absorb ng init. Kaya nangyayari, pag na-absorb ng ocean ang init na nanggagaling sa araw, ang init na yon mag-evaporate siya ng madaming tubig at yung ocean parang nagbibigay siya ng init sa atmosphere. Parang bumababa ang init sa ocean, ang ocean tinataas niya ang init palabas, papuntang atmosphere. Discuss natin mamaya circulation na yan. So sa third point naman natin, these atmospheric circulations result in our weather systems that include mid-latitude storms and hurricanes. Once in motion, the atmosphere drives additional ocean circulation through the exchange of momentum across the air-sea interface that drives waves and currents. So kung ang ocean nagbibigay siya ng mga tubig sa atmosphere, ang atmosphere naman, nagbababa din siyang tubig at may kasama tong waves and currents. Dahil sa wind na dala-dala ng atmosphere, nagagalaw niya ang tubig sa oceans, resulting in waves and currents, both in the surface and the deep waters of ocean. Yan. Let's continue. One way that the world's ocean affects weather and climate is by playing an important role in keeping our planet warm. Malaking tulong ang nabibigay ng araw, ng dagat, at ng atmosphere natin sa mundo natin kasi kailangan ng warmth sa Earth. And warmth is a sign of life. At ang ocean at ang atmosphere, talagang nagtutulungan sila to bring warmth sa buong mundo natin. By weather or by climate man yan. The majority of the radiation from the sun is absorbed by the ocean, particularly in tropical waters around the equator. Sinabi ko kanina, tropical seas, nandun yung warm waters, where the ocean acts like a massive heat-retaining solar panel. Nag-a-absorb ng init pala ang ocean. Gaya ng masulas information na to. Land areas also absorb some sunlight, and the atmosphere helps to retain heat that would otherwise quickly radiate into space after sunset. The next is the relationship of ocean with the weather and the climate. And since we're talking about the ocean and the atmosphere interaction, syempre hindi natin lalaktawan to ang relationship ng ocean sa weather and climate and how the ocean affects weather and the climate. Now, the oceans and the atmosphere are the two large reservoirs of water in the Earth's hydrologic cycle. The two systems are complexly linked to one another and are responsible for Earth's weather and climate. The oceans help to regulate the temperature in the lower part of the atmosphere. Diba? Sabi ko kanina yun. Now, the atmosphere is in large part responsible for the circulation of ocean water through waves and currents. Kita niyo yung give and take ng ocean and the atmosphere. Give and take sila, diba? Ang ocean, nagbibigay siya ng tubig sa atmosphere at ang atmosphere, nagbibigay siya ng tubig sa ocean through waves and currents and through rains din, syempre. Like thermodynamic nga, di ba? Thermodynamic, nagbibigayan sila ng energy para magkaroon ng balanse or nagbibigay sila ng energy para ma-maintain yung temperature ng Earth. Umiinit, lumalamig, umiinit, lumalamig. Climate, seasons, di ba?